Hello friends, I am Radhakant Joshi. Today I am going to talk about noise. It is a very important topic in communication system and we need to focus on that. Let us see what is the noise first. A noise is an undesirable portion of an electrical signal that it interferes with an intelligence. Why I call this an electrical signal? Because most of the signal we used in the communication system is electrical signal. Rather, there is also we use the optical signal, and there also exists in the noise. So it is an unwanted modification in the signal while transmitting, storing, or capturing the signal. So we have to learn about how to minimize the noise. So why it is important to study the effect of the noise actually. Today the telecom network is going day to day life, so the number of channels also increases and the effect of the noise is also increasing. The switching equipments needs to handle high traffic volume as well. Our ability to recover the required data without error is inversely proportional to the magnitude of the noise. If the noise magnitude is more, then we have to design such system that will minimize the error. So the magnitude increases, noise magnitude increases, the complexity of the circuit may increase. So we should study about the effect of the noise and how to avoid it. Let us highlight some of the point how to minimize the effect. In the data transmission system or communication system, we use special encoding or decoding techniques in the receiver and the transmitter side to optimize the signal. The transmission medium is also chosen based on the bandwidth, that amount of the bandwidth we use. It is end-to-end reliability requirements. Suppose we don't need high reliable system, then we will use some other techniques. So based on the requirement also we choose the transmission medium. The anticipated surrounding noise level and the distance to destination. The distance is more, then the noise effect may be more. So to elaborate the error detection and correction mechanism utilized in the communication system. Types of noise. The few types of noise are there: atmospheric or extraterrestrial noise, Gaussian noise, crosstalk noise, impulse noise. What is an atmospheric or extraterrestrial noise? The noise that is caused by the atmospheric signal, that is the atmosphere, is called the atmospheric noise, like lightning, solar noise, or cosmic noise. While lightning, the static discharge generates a wide range of frequency that interferes with the communication system, that is wireless communication system. So we get a high voltage, that is undesired voltage in between the transmitter to the receiver due to the lightning. So it is an undesired signal, and it is a part of the noise. The solar noise also produce the high frequency which is undesired in communication system. The same as the communication, cosmic noise also radiates intense level of noise frequency, and that penetrates the Earth's atmospheres, and that is also undesirable. It is called the atmospheric or extraterrestrial noise. Gaussian noise. What is the Gaussian noise actually? There are different kind of noise, and if we take the cumulative effect of all the random noise generated over a period of time, it is called the Gaussian noise. What is a thermal noise? It is generated by the random motion of free electrons and molecular vibration in resistive components. The power associated with the thermal noise is proportional to the both temperature and the bandwidth. We can calculate the power associated with the thermal noise with this formula shown in the PPT, that is K into T into BW. That is where the K is the Boltzmann constant, T is the absolute temperature of the device, and the circuit bandwidth. What is a short noise? It is mostly occurred in semiconductor or the vacuum tube devices. It results from the random arrival rate of discrete current carriers at the output electrodes of the semiconductor and the vacuum tube device. noise current associated with the short noise can be computed as In equal to root over of 2q if, where In is the short noise current in RMS, that is root mean square value, and q is the charge of the electron, and I is the sorry DC current flowing through the device, and F is the system bandwidth in Hertz. Let us see what is a crosstalk. It is an electrical noise or interference caused by the inductive and capacitive coupling of signal from adjacent channel. I will explain with a detailed diagram. In local area networking, that is LAN, the crosstalk noise has greater effect on the system performance than any other type of noise. So problem remedied by using the UTP or STP by twisting the cable pair together. The electromotive force, that is EMF, surrounding of the wires cancel out each other. That is a unwanted signal which is generated due to this twisting of the cable. So we have to avoid this kind of error also. In this diagram we can see that the transmitter to the receiver channel is there, and the crosstalk are of two types, that is nearer end crosstalk and far end crosstalk. What is the near end crosstalk? It occurs at the transmitting station mainly when the strong signal radiating from the transmitting pair of the wires are coupled in two adjacent weak received signal traveling in opposite direction, as shown in this portion, where the transmission to receiver the the direction of the transmission is different. It is a near end crosstalk. In far end crosstalk occurs at the far end receiver as a result of adjacent signal traveling in the same direction. In this medium, the two signals are transmitted in two different medium in the same direction. Here we may encounter the far end crosstalk. Crosstalk in practical we can see in telecommunication service while we are talking to in the land phone mainly, or in mobile phone nowadays also, we may listen some of the voice from the other channel. That is called the crosstalk. What is the minimization technique we use for the crosstalk in telecommunication system? By using the twisted pair of wires, using shielding to prevent signal from radiating into the other conductors. Suppose the two wires are like this, so we have to use proper shielding so that this signal should not interfere this signal. The transmitter and receiver signal over a long distance are physically separated and shielded. Differential amplifier and receivers are used to reject common mode signal. Balanced transformers are used with twisted pair media to cancel the crosstalk signal coupled equally in both lines. Maximum channels used within the cable are limited to certain values. What is an impulse noise? A noise consisting of sudden bursts of irregular shaped pulses lasting from the few microseconds to several hundred milliseconds. What is cause of impulse noise? The electromechanical switching relays are at the CO, electrical motor and appliances, ignition system, and lightning. If a sudden pulse come in between the signal, that is unwanted, that is called the impulse noise. What is the signal to noise ratio? It is the ratio of signal power to the noise power at the some point in telecom system expressed in decibel. It is typically measured at the receiving end of the communication system before the detection of the signal. It is the most important part of the noise detection which is done before the detection of the signal in the receiver side. It is expressed as mainly decibel. SNR, that is signal to noise ratio, equal to 10 log signal power by the noise power in decibel. We can see the formula that 10 log Vs by V in, that is signal power, that signal voltage to the noise voltage square is equal to 20 log Vs by V in. What is the noise factor? It is the measure of how noisy a device is, whether it is a less noisy device or the more noisy device is. Noise figure is equal to the noise factor expressed in dB, where F is the noise factor, which is the signal to noise ratio in the input side to the signal to noise ratio in the output side, where it is noise ratio is calculated in 10 log F, that is the noise factor. It is in the logarithmic scale. The amount of noise added by the network is embodied in the noise factor F, which is defined as the noise factor signal to noise ratio input by the signal to noise ratio output. It is if the noiseless network, in the noiseless network, the F value is less than or equal to 1, whereas generally is F is greater than 1. The noise figure in the noise factor quoted in dB, that is it is calculated in decibel, that is 10 log 10 base 10 F. The noise figure of the factor is the measure of how much the network degrades the signal to noise ratio. The lower the value of noise factor, the better the network. If it is equal to 1, then it is called the noiseless network, and that is very difficult to get. What is a bit error rate? It is occurs in the digital transmission system while we transmit 0 in terms of 0 and 1. The number of bits that are corrupted or destroyed during the transmission is called the bit error rate. Suppose we say 10 to the power minus 5 bit rate bit error rate, that it indicates 1 bit out of every 1 lakh bit is destroyed during the transmission. The factors governing bit error rates are bandwidth, signal to noise ratio, transmission media, environment surrounding the media, transmission distance, and the transmitter and the receiver performance. Let us see some of the noiseless amplifier that is affected by the noise. It is the shown diagram is the ideal noiseless amplifier, where we can see the signal to noise ratio in the input side is equal to the signal to noise ratio on the output side. So there is no noise in the amplification, which is very difficult to get. So there is no ideal amplifier which is noiseless. So the non-ideal amplifiers shown in the figure, the signal to noise ratio is affected by the noise, that is the power gain. AP is the power gain, and is the internally generated noise in the amplifier. Some voltage may be occurs due to some noise signal. So the formula shows that AP SI by AP NI into plus ND is the signal to noise power ratio. The noise figure of cascade amplifier. The cascade amplifier, we cascade the number amplified to get the more and more gain. In this also we encounter some of the noise. And the signal to noise ratio is calculated as the formula S0 by N0 equal to SI by NI plus NFT, where the total noise factor is the accumulation of the individual noise factor in each of the amplifier. The noise is being calculated and it is accumulated to get the total noise. In Friis formula, we used to calculate the total noise factor of several cascade amplifier as shown in the formula in the slide. Ft is equal to F1 plus F2 minus 1 by A1. A1 is the gain of the first amplifier, and F3 minus 1 by A1 A2, that is the A1 is the gain of the first amplifier, A2 is the second gain of the second amplifier, and so on. Thank you.